Okay, so this one we're going to solve graphing a function. We're going to find the domain and the range. And then we're going to tell whether the relation is a function. So using a graph, we can look at a few points for x. We have 5, 8, or x and y. 5, 8, 8, 5, 8, 4, 10, 3, 12, 1. So we need to determine, is there a pattern here? Well, we notice that the difference between 5 and 8 is plus 3. So it could be a combination of multiplication and addition. We don't know yet. Then we have 8 to 5. Well, 8 to 5 is subtracting 3. So we can see that those two don't really relate to each other, but we need to look at a few more numbers to see. So then we notice that it also has 8 and 4. Well, if it was a function, then when we get 8 as our input, our output would always be the same. If at one time we get 5 and then another time it's 4, then that represents that it's not a function. So this one, number 1, is not a function. And if it's not a function, then that means that there's no equation. Now the domain and range, that we can look at. So we remember when we look at range means the set of all input values. So what does that mean? Our input in this case are our x values, all the values from x. So our domain is all of our input values. The range is all of our output values. So that would be our values for y. So we can just say our domain is 5, 8, 10, and 12. Our range is 8, 5, 4, 3, and 1. And it is not a function. Now problem 2, it might be easier for you to rewrite this in the same format as the first situation using your x and y. Well, we know that when we have parentheses, we always put it in alphabetical order, in order of x and y. So our x is negative 5. Our y is negative 2. When our x is 2, our y, is 5. When it's 7, we have 10. And when it's 9, we have 12. So that might be easier for you for graphing purposes and to look for a pattern. Well, we can see when we have negative 5, our output is negative 2. When we can calculate the difference there, of course, is positive 3. Now we need to see if that's the same pattern for the rest. It could be a multiplication plus something. We don't know yet. So far we have plus 3. Well, 2 and 5, the relationship there is also plus 3. Between 7 and 10, also plus 3. And 9 and 12, also plus 3. So whatever my input is, or my x, my y equals x plus 3. So that is the function. And then, of course, the domain is negative 5, 2, 7, and 9. And our range, all of our y's, is negative 2, 5, 10, and 12. And when you get into higher levels of mathematics, you're going to word it a little differently. For example, all real numbers. But in 6th grade, all you need to do is list the numbers. So now I'm just going to represent this graph, this function, on a graph. So here we have our y, here we have our x. And our first point to plot is negative 5. So I, of course, start at 0, 0, 1, 2, 3, 4, 5 to the negative side. and -2, down 2. So my first plot is there. Then we have +2, 1, 2, +5, 1, 2, 3, 4, 5, 7 and 10. 10 is going to be all the way at the top. And then I can draw a straight line, as straight as I can, through to represent the graph. So that's how you graph a function. In our next three problems, we're going to graph the line through the given points. So basically, they're kind of saying that it is a function. So we start with 2. So we go over 1, 2. And we go up 6, so we go up to the 6 and plot that point. And then we go 6 over 6 and up 1. So we have our 2 points plotted, and then I'm going to graph a line through this. And I notice that my line, because I plotted it correctly, I can see is a negative graph because my arrow is to the left. My top arrow is to the left. Now let's look at our second example, graphing 3 and 2. Of course, 3 is our x, so we go over our x to 3, up to 2 for our y. Then we go x5, so to the 5, and up 2. So I notice that this one, of course, has a slope of 0 because I have no rise. I only have a run. So this is a neutral graph, or a slope of 0. And in my third point, I need to, of course, go over 4 and up 4, because it's +4, +4. Then I go 4, 0. And, of course, this graph has no run. This is also a straight line, but this is a straight line up and down. So this is not a slope of 0, by the way. All right, in our last examples, we're going to find the slope of a line. And I'm going to show you both ways of finding the slope. So looking at the slope, the first example, I'm just going to use the good old rise over run method. So our rise here, we start at one point, we go up 1, 2, 3. So that's a rise of 3. And our run is going to be 1, 2. So our slope is 3/2. In our next example, I'm going to also use rise over run. In fact, in all of these problems, it's a little bit easier to use rise over run, but I want to just demonstrate both ways. So here we have slope, of course, is the change in y over the change in x, or the difference. 1, 2. Again, +2 over 1, 2, 3, 4, 5, +5. So my slope is +2/5. In my last example, I'm going to demonstrate this both ways. Of course, we have a rise of -1 and a run of 1, 2, 3, 4. So that would be -1 over 4, or -1/4. Now another way of doing this, of course, is the difference in the y's, y1 and y2, over x1 and x2. So I am going to demonstrate that. So first, looking at our y's. So here we have our y at +3 minus, and then my next one is at +2. Then I have my x's. I have my first x is at 1 minus 5. So when I find the difference, I can just say, okay, well, 3 minus 2 is 1. 1 minus 5, again, my same change rule when subtracting numbers. So I have 1 plus negative 5, 1 positive, and 5 negatives gives me 1 neutral and 4 negatives. So it's negative 1/4. So either way, I'm going to get the same answer. And I know in this graph it's easier to just use rise over run, but in this graph I wanted to demonstrate both ways because you might have some more difficult graphs down the line.